Okay, last talk today, aside from the newest functionality, so no pressure at all. We're based in Inverness, and we are carrying out massive data sets, or massive surveys that we use colossal data sets. Okay, a bit of background. First of all, during today I'm going to go a wee background about the company, a wee insight into what we do, the types of surveys we're carrying out, the reasons we're carrying them out, and then I'm going to show some of the projects we've been compiling over the last 6 months. There's also some new functionality that's been added to Enforce that I'll touch on briefly in the last couple of weeks. Thank you for that. So we're quite a young company. I only took over the company in 2005 from my father. Up until that point it was mainly oil and gas. When I took over, I wasn't really interested in surveying. It was all setting out, which I realised I didn't really like doing. Let's face it, you go and set out 50 houses and then a forklift drives over about 20% of the pegs. So in 2007 I started land surveying, which was adding to my existing Cadd skills, which I'd established in oil before I'd started setting out. 2009 I believe it was, ish. 1.12, when was that? About then. Up until Enforce we were using Terra model, which is horrific. Now the drawings that we could compile using Enforce were far superior. It was, even back then, there was no functionality for point clouds and so forth that I knew of. It's probably lurking in the background of their brains somewhere. But the drawing quality went up straight away. During the downturn, which was horrific, I moved away. I did work in the dimensional control industry. It was, again, just adding to that existing Cadd skills. I was just shown how to actually measure a point and being realistic, know when you're measuring to 0.1 of a mil or 10 mil. Bewley-Denny, 2011, that saw a massive step change for the company. We went from 2 staff to 12 in 2 months, which was a lot of grey hairs, balancing monies. In 2012 saw the first Faro scanner we bought, which was as good as Terra model. Then changed scanners and advanced the workflows that we've been carrying out. We gained the permission to work for the UAVs in 2014, which, to be honest, it was about that time that UAVs started becoming useful. I'd had a demonstration of a Trimble system that, when it comes into land, it's a cruise missile. It doesn't matter who's standing there, what cow has now moved into the location, it's hitting the spot that you set. It wasn't really for us. We work in Scotland. We're very tight landing areas. You can't afford to have a 100 by 100 square metre field. So that's why we went with the Sirius Pro. At this stage I'll say my other company is Northern Survey Supplies. You probably saw a van outside, which we resell Topcon, which is why initially we were guided to the Sirius. The joys of the Sirius is when we flick the switch into full manual, it becomes just a standard RC plane. Granted, when we bought it, a £60,000 remote control plane, but an RC plane nonetheless. Now, 2015 saw, I think it was 2015. When did Cockermouth flood the first?
2009.
Okay, next time. 2015. So 2015 saw us, we were actually awarded well, we weren't awarded, we applied for EVLOS with the CAA. To people that don't know what EVLOS is, that's Extended Visual Line of Sight. We've got 1,500 metres and we've also got nuclear permissions. Now, that involved a lot of paperwork and meetings with Civil Aviation Authority. Now, that then opens up all manners of work. We flew Cockermouth in 2015, very early one Saturday morning. It was -6 or -7 at the time. It wasn't nice. The army were there clearing up everybody's belongings in the skips, unfortunately. But we then, moving forward, we purchased the boat last year, and we secured that in August, and that's go out with an orbit multibeam. And lastly, we're now about 23 staff, and we're looking for more. So going on, just going to touch briefly, well, more in depth to be honest, with the UAVs. So what we found out when we bought the kit, the developer basically said, here's a box, enjoy it. So we had to then go and develop a workflow. Now, we tried a couple of processing softwares, looked at Pix4D, Agisoft. In the end, Pix4D, the repeatability of the surface was absolutely diabolical. So if you repeated the same data set multiple times, you would get different answers. So that, for us, we couldn't rely on it. Whereas with Agisoft, it was rock solid. We could believe what we were seeing. As well as that, we carry out verification surveys. So similar to what LiDAR companies go and get control established, we'll go and survey GCPs and also truthing patches. So we can compare our surveys, granted surveyed using GPS or total station, depends on the tolerances of the job. And we compare that to the survey that we're carrying out. Now at the time, again, this is back in 2015, we used another software, Virtual Surveyor. It was good at the time. It did what we needed. They developed the software to head off in another direction, which we didn't really want. So we didn't really develop with that software. Meanwhile, applications in Cadd, they've been doing a lot more work with the software, so it meant that we could actually see, instead of using multiple softwares, we're getting everything under one roof, and you're saving time and workflow. This is just a wee flight that Craig did with Falcon 8 of a city centre school that's getting a new building built. Bizarrely, with our client for this job, all they wanted was the point cloud and images, which is fine. It's a lot less processing. Bathymetrics, so as mentioned, purchased that last year. Last year we saw a shift in what our clients were looking for from us. Up until then, I would say most of the time people were just wanting, excuse the terminology, but a dumb 2D drawing. They don't want any 3D aspects in it at all. But last year we started scanning major structures for the transport network, and that involved from the top of the bridge right down to the riverbed or the seabed. I subcontracted a company to come in with a cheetah, the same as a cheetah catamaran. It was on the last set of slides. The cost was absolutely phenomenal, huge. So I thought, well, why am I putting all this money to them when at the end of the day I'm just getting a point cloud that I had to go and look at and filter myself anyway. So put it this way, what we paid last year would have paid 15% of that boat and multibeam off in one contract. So immediately I thought, why are we doing it? So purchased that, went over to California to get training on it, which I sold to the wife as a hard week. But it's very strange over there because you go into the water and it's like you're standing in a bath. We went to a reservoir and walked out in shorts, and it's warm. It is like just being in the bath. What we have found out is the QPS software that we use for the processing the sonar data is designed for sonar. It's not really designed for combining with our other data sets. It's good at exporting a point grid and colorized images, very nice. But also, recently, what I will say, using Inforce Designer, you can generate the georeference imaging, which is better quality if you play with the lighting than we are getting out of the sonar software. So it has, again, gone into it. This is just a wee video of the vessel. Again, it's traditional RC, unless we put it into autonav mode. Unlike a UAV, you can see a tree with the UAV. You can't see underwater structures, and you don't want a £100,000 mistake when you collide the sonar off a submerged rock, whatever. So you tend to use the RC, the transmitter, and carry out safety lines right around your loch, and then lakes down here, round the loch, and then you would bulk fill in using the autonav. Now this is a multibeam data set with one of our solid models. Now that is the only solid model in this presentation that is not shot in Inforce. Okay? Bear that in mind. Now with that project, how do you go back?
Just the arrow key back should come.
Oh.
We can just use that, yeah. Might play, go back again.
Right, okay, so what you will see on this one, you can see the caps, but also you can see kelp and so forth going around it. That's just a gridded surface that was exported from the software into Inforce, tidied up, and then exported to, that was in Navisworks, that project. So advances in Inforce. So again, a year ago, we started seeing a massive step change in Inforce. What it meant is it reduced our workflow significantly. We dropped, as I mentioned about the other software, we dropped that out because we could generate everything. As you can see in the bottom, it's for a pre-start survey next to the road. All I was using the strings there for was to check that it tied in with the original ground survey that we'd been issued. But it does mean now that we can generate a single model using all the data sets. So whether it be the UAV, the USV, the scanner, traditional topo, we do a lot of corridor surveys for long transmission cable routes. We're talking, the shortest one we've done is 20k, 80k is longest, and that'll cover all sorts of terrain. We use Top One IPS3 mounted to a Shogun for the road network. We use the UAV, both that and the Falcon, the boat. We've got guys out on the ground. We're tracing cables. We're creating one model that you can export in Cadd at the end of the day and give that to the client. Now, one other thing I will talk about, there was a talk about machine control earlier on. So this survey here, that was on the flight path to Inverness Airport, about 1,500 metres off the numbers. Now, that site was flown using the Sirius and machine control. What it meant was that there was nobody walking about on the site, meaning that there was no risk to our operators. Because ultimately, at the end of the day, there were quite a few bits of plant, albeit you wouldn't believe it looking at that, but there was quite a few bits of plant moving about, and they were very concerned about, it was for a large factory, and they didn't want any statistics adding to their job. Now, as I said, The last one was the only video that wasn't created in Enforce. That there is 3D solids imported into Enforce as of 2 weeks ago. I'll show the project in a few minutes. But again, that's using our multibeam. We scanned the bridge using an IPS-3 mounted to a cheetah catamaran. We laser scanned the ends of the bridge, and also we used the IPS-3 on the top of a shogun for the top of the structure. Okay, I'm going to show you some of the projects. So what did I need to do, Andrew? Okay, so this project is a valley that what they're going to do is they're going to build a dam and flood it and raise the level by 4 meters. There's already an existing loch there. Now, the deliverable for this project was point cloud, the whole thing, a LiDAR grid file, 3D contours, and imaging. Now,
You should have loaded by now.
my laptop's faster than this one. I thought HAL was amazing. Oh, here we go. Right. Okay. No. Okay, so what we've got here is Bathy created using the boat, and then we've got photogrammetry data from our plane and also a Cessna 172. Laser scan the bridge, and then we've draped our imaging over the top. Again, it's a colossal data set. The grid was 250 mil as spec'd by the client. I wouldn't have said 250s required on a project that size, but that's what the client wants, so that's what they get. They did say afterwards that they struggled to open the Cadd. So it is what it is. So what we have done here, I was talking about the height shading in Enforce is better than the sonar software. So we generate the height shading, save the ortho image, and then Craig, he's the wizard with Photoshop, he dropped that on top of the aerial image, and then we re-imported the image. So you get the height shading, but without having to use the height shading option over here. I have asked for it, and I've been told. Okay, so that's one project. Again, absolutely massive. You can actually see, going by the colour, where the UAV stopped. So the UAV was here. There was 140 metre height difference along the edge here. So that's why we were like, no, let's just... whilst we do, with our EVLOS, we've got 600 feet. So, in theory, could have done it, but no thanks. Go into this one first. Make it a bit easier, I think. Hopefully. Right then. I'm loving the sound effects.
So,
Unintended.
so new feature.
Okay. Ta-da! So this is the new feature that we had added in, and we actually used Navisworks to present this to the client because they've got an Autodesk license with one of the suites, so they had Navisworks, but it's a lot more clunky than this, so it would have been a lot easier to issue it with this, to be honest. With this project, you'll see the rock armour around the legs, and not in some cases. But we've, since doing this project, mainly this one, the client has now come back saying that they've approved a budget for us to redo this bridge every year. So we can now check for scouring. Not real time, but it's at a often enough that they can address any issues before they become issues. Interestingly enough, this leg here, that leg had as much rock armour as this one here. It lasted about 4 months, and then it was all washed away. So they're going to put a concrete mat over it now. But it's, yeah. Okay, so that's again one of their new functionalities. And okay, in this project we utilised, first of all, the initial scope was just to create a Cadd model of the bridge. I'm going to also do the same here. Yeah. Yeah, so our initial task for this was just to laser scan it, measure the rails using total station, because it's actually the 3D printed model there. That's what this one is going to be. Afterwards, the client then replaced the rails, and then we went back and laser scanned it again. But whilst we were talking to them, we suggested using because we originally scanned that bridge before we got the boat. So we had a single beam sounder fitted to a glorified bait boat that Craig built, and it worked. We did colossal amounts of cross sections using it. We did the River Erne. I think there was 120 cross sections we did there for your Scottish counterparts. Now, it demonstrated the weaknesses of RC technology, which is why one of the reasons that we wanted to go to that size of boat so we could offer more when we were carrying out these surveys. Now, yeah, we suggested that we would use the boat, and at the same time we used the Falcon 8 as well, just modelled. So what I'm going to show you is a combination of 3D laser scan, the boat and the plane in Enforce. Now the 3D scan, we did have, we also do small amounts of modelling myself. We had it built for us. When you're praying, everything works. Now, it's this software now is phenomenal. It was always good, don't get me wrong, but see for us to verify the models that are coming back, okay, we tend to use Cadd a lot for that, but see if we want to check that surfaces are tying in, sanity check it basically. This software is offering a lot more. We can prepare videos for the client, presentation videos straight out of here as well. It's absolutely phenomenal. It's reducing our workflow no end. Our profit margins are going up because of that. Yeah, it's moving the right direction all the time. Is there any questions?
Got to be one.
We've had contractors offer to do multibeam for us and scan the banks as well from the boat.
Yep.
Our concern is that it's the interface between the two data sets. They gave us some sample data and there was a definite gap, so you didn't know
Yep.
whether it was a straight line between the two data sets or whether there was a cliff or what. So yeah, it's
Okay, with multi-beam technology, the one that we use is an orbit. It uses a curved array. Now that means that you can get right at 210 degree swathe. With the older ones, it's a flat array, and therefore you're limited to how much, unless you physically rotate the sonar head over to one side, then you're not going to get to surface level. With this kind of technology, the sonar technology, the main thing is your sound velocity in water. If that is wrong at all, then if you're going horizontally through the water with the sonar, you tend to get a massive error in basically the slope distance.
yeah.
So regular dips with SVP is absolutely vital if you're going to be going near surface. What tends to happen is it looks like the sonar is tracing out, it goes almost horizontal underneath the surface from the UAV or whatever you're surveying. A lot of these, like we can mount what's a Teledyne LiDAR profiler to the top of that. It's not great. It's not, I wouldn't say it's survey accurate. And also you've got to have, whilst the IMU in that is extremely high end, it's a 0.01 degree system, it's, once you start going hundreds of meters with effectively what you can do with LiDAR profiler, it is not going to be as great. And
Yeah, because we were concerned as well about vegetation on the banks. You'd end up with big shadows behind and you wouldn't know what the slope was doing. So, and the output from that job was just to produce cross sections for flood modelling. So they were kind of using a sledgehammer to crack a nut really, and we'd rather have, traditional survey with a pole.
Also, what you don't get with the multi-beam is hard and soft bed levels. What you can do is analyse the backscatter. Now, if you're doing that, you really need depth and lots of overlap, and none of which you can really do in rivers.
No.